In the time of the Civil War, disease was the leading cause of death. The diseases that were the biggest killers during the Civil War were dysentery, typhoid, pneumonia, tuberculosis, malaria, and measles. These diseases were often found in prisoners because the camps and prisons were so unsanitary. It was a great way for dysentery to spread around. The most important medical advancement during the Civil War was amputation. Amputation was the most successful medical procedure during the Civil War, saving many people's lives. Another great medical advancement was anesthesia. This would knock the patients out when needing amputations. Anesthesia didn't technically save lives, but it helped the amputation procedure carry through without many obstacles.
The first antibiotic was penicillin, which was discovered by Alexander Fleming in 1928. The antibiotic was actually discovered in a rather interesting way. Fleming was sorting through petri dishes containing colonies of Staphylococcus, which is bacteria that cause boils, sore throats, and abscesses. As he was doing so, he noticed something unusual on the one dish. After some careful investigation and observation, he found that his mold juice was capable of killing a wide range of harmful bacteria, such as Streptococcus, Meningococcus, and Diphtheria bacillus. He published his findings in the British Journal of Experimental Pathology in June of 1929 and did not disclose all of penicillin's potential therapeutic benefits. This discovery was greatly important to the medical field because it was the first time that there was a cure for any sickness. Penicillin was used to protect mice against infection from streptococcus, a deadly disease. This drug had a huge impact on people, especially the people involved in World War II, which is the only war that helped promote the discovery of penicillin. The word got around that there was an antibiotic known as the miracle drug, which then led to many British colonies buying the drug. It impacted the people involved in the war majorly because it was the only drug that was out there to heal their wounds. Other discoveries of antibiotics include the discovery of streptomycin in 1943, cephalosporins, glycosylvin, which is used to treat athlete's foot, bacitracin, polymyxin B, amphotericin B, erythromycin, neomycin, streptomycin, tetracycline, vancomycin, gentamicin, and rifamycin.
Hand hygiene is very important in the medical field because the doctors can transmit diseases from one patient to another with their hands. It is said that some viruses can survive for up to 3 hours on something such as a doorknob. That's when in 1847, a physician in a Vienna hospital found that most diseases were commonly spread from patient to patient by the doctors that didn't wash their hands in between examinations. Hand hygiene is important for so many things, such as reducing the spreading of diseases in hospitals, but it is also important for everyone to wash their hands after any activity. There should be hand hygiene for anywhere that there is a large amount of bacteria, such as the bathroom.
Antibiotics work by affecting things that bacterial cells have but human cells don't. Antibiotics are extremely important in our lives because they cure diseases and bacterial infections, some that are even deadly. Without antibiotics, we would still not have cures for some diseases and some sicknesses. Without antibiotics, thousands of people would be dead due to a sickness they once had. Amoxicillin is used to treat respiratory viruses. Azithromycin is used to treat coughs. Phenoxymethylpenicillin is used to treat pharyngitis. Chloramphenicol eye drops are used to treat conjunctivitis. Benzopenicillin is used to treat arterial meningitis and suspected meningococcal sepsis. One precaution that people can take is protecting the elderly, as they are fragile and may have chronic medical conditions and are more likely to develop an acute infection. Another precaution you can take is to wash your hands after using the bathroom, before preparing food, after touching wounds you have, and after blowing or rubbing your nose. One last precaution you can take is to use an alcohol-based hand sanitizer frequently.
As you know, there are bad bacteria, but there are actually 5 good bacteria, which are called Lactobacillus, Bifidobacterium, Streptococcus, and Bacillus coagulans. Lactobacillus goes into the intestines to help with digestion and produces lactic acid and hydrogen peroxide, which create unfavorable conditions for the growth of harmful bacteria. Scientists have found that Bifidobacterium can help to repair stomach ulcers caused by Helicobacter pylori. It can be useful for childhood constipation. Streptococcus is known as a reliever of abdominal cramps, diarrhea, nausea, and other gastrointestinal symptoms associated with lactose intolerance. Streptococcus can also help with bad breath. Bacillus is a dietary supplement that is used for various concerns. It is also useful in the treatment of gastrointestinal disorders such as diarrhea associated with an antibiotic regimen, travelers and children's diarrhea, inflammatory bowel disease, and irritable bowel syndrome. We as humans can live without these good bacteria because these bacteria just help ease the pains and problems. They're not fully getting rid of these things.
Antibiotic resistance occurs when an antibiotic has lost its ability to effectively control or kill bacterial growth. This should be a concern because it provides reason for us to not be able to trust 100% that the antibiotic will work. It also means that the person could still be contagious, which means others could still pick up the virus. Antibiotic resistance is a natural occurrence. However, bacteria may also become resistant by either a genetic mutation or by acquiring resistance from another bacterium. You can prevent resistance to antibiotics several ways. One way is to not take an antibiotic for a viral infection like a cold or the flu. Another way is to not save some of your antibiotics for the next time you get sick. Discard of any leftovers that you have. Types of antibiotic resistance include intrinsic resistance, acquired resistance, such as genetic change, as well as DNA transfer.
Antibacterial products are basically everywhere now because they are known for helping to prevent the spreading of infections. But are they really doing that? Antibacterial products do not prevent infections any more than good personal and household hygiene by using normal soaps, warm water, and detergents. Antibacterial products are not always a good thing. Yes, it does kill bad bacteria, but it also kills the good bacteria that helps us. Although the antibacterial products kill most bacteria, some may survive and multiply. These surviving bacteria become resistant to antibiotics and disinfectants. When using antibacterial products, the quote, "more is better," does not apply. Some common antibacterial products are soaps, detergents, hand lotions, window cleaners, surface sprays, mouthwash, and toothpaste.
Some bacteria and diseases that have become antibiotic resistant include methicillin-resistant Staphylococcus aureus, vancomycin intermediate and resistant Staphylococcus aureus, community-acquired methicillin-resistant Staphylococcus aureus, Streptococcus pneumonia, which is a multi-drug resistance, E. coli, CTXM, extended spectrum beta-lactamases, which is a multi-drug resistant strains, Klebsiella pneumonia, extended spectrum beta-lactamases, multi-drug resistant Mycobacterium tubulosis, Anitobacterium baumannii, and Staphylococcus epidermis, which is methicillin resistant. They are so dangerous because antibiotic resistance can cause infections, and there may be no antibiotics that are effective for the infection. This could be life-threatening in a serious infection. They can spread in a situation of either the illness being contagious or a skin irritation being shared. To control this problem, patients should avoid using antibiotics that were prescribed for someone else, and they shouldn't share their antibiotics with others. Also, patients should discard of any antibiotic that may be left over from a previous illness and should not save it for the use of another infection. This is because it may not be the right antibiotic that is needed for the next illness, it may be out of date and ineffective, or there may not be enough medication to treat a current infection. In the future, antibiotic resistance will hopefully be less of a problem. The Food and Drug Administrations and the Centers for Disease Control have launched initiatives to help address antibiotic resistance. Research is also continually being done on how to prevent antibiotic resistance. Probiotics could have a part to play in slowing down the spread of antibiotic resistance. Certain strains of probiotics have been demonstrated in clinical trials to prevent the side effects associated with antibiotics. Probiotics would help this situation because they increase the number of good bacteria in your body, which would create prevention from antibiotic resistance.